Hello physical science students. Today we are going to talk about dimensional analysis, otherwise known as converting units. And basically this is just how to say how much of something we have in a different way. So for example, if I have 1 gallon of milk, it's the same thing as having 4 quarts of milk or having 8 pints of milk. It doesn't change how much milk I have. It's the same amount, we just say it in a different way. Another example would be if I run a race that is 5 kilometers long, I could also say that I ran a race that was 3.1 miles long. It's the same distance, it's just said in a different way with different units. And because the units are different, the numbers are different as well. So the question becomes, how do we do this? How do we change one unit to another unit? And when we do dimensional analysis in science, we basically go through the same process every time. We take an unknown value. This is what the problem is asking us for, and we represent that with the letter X and the units that we're trying to find. We set that equal to what we already know. This is the known value. It's the amount that's given in the question. And then we take that known value and we multiply it times a conversion factor. Now, a conversion factor is the tool, it's the bridge between the known value and the unknown value. It typically is in the form of a fraction. The top and bottom each have different units and different numbers. Usually, I can think of one example where they don't, but for the most part, the top and bottom will be different. We know what our conversion factor is going to be based on either it's what's given to us in the problem, or we can look it up on a conversion sheet. Now the conversion sheet looks like this, and it tells us a lot of different information, like 1 kilogram is 1,000 grams. It tells us 1 pound is 16 ounces. It also tells us that 1 kilometer is the same as 1,000 meters. There are lots of different things that we can see on here. So that is something we would look up. Then we have 2 values. So for example, 1 kilometer is 1,000 meters. One of those values has to go on top. One of those values has to go on bottom of the fraction. The one we want to keep, the unit of the unknown value, is typically the one that goes on top. Sometimes it isn't, but for the most part it is. And finally, you may need more than one conversion factor. We're going to start out with just one-step dimensional analysis problems where we only need one conversion factor, but I'll do an example where we need more than one. All right, so let's get to the first example. And example 1, how many centimeters are in 2 meters? So we want to go through that same process I talked about before, where we take our unknown value, we set it equal to our known value, and we're going to multiply that by our conversion factor. So in this case, what is the unknown value? Well, we look at our question and which one is associated with the question word. How many centimeters? That is our unknown value. So I'm going to represent that with X centimeters. X because I don't know. Centimeters because that's what I really want. The known value in this case is 2 meters. So I'm going to just write it down as it is, 2 meters. Now, I need a conversion factor. I need something that sets meters and centimeters together. So I'm going to look on my conversion factor sheet and see if I can find something that sets meters and centimeters together. And sure enough, here I have 1 meter equals 100 centimeters. So one of those 2 values, let me write that down first, 1 meter equals 100 centimeters. So in my conversion factor, which is going to take the form of a fraction, one of those has to go on top and one has to go on the bottom. Now the thing I want is centimeters, and so that is going to go on top. The thing I want to get rid of is meters. That's going to go on the bottom. Okay, so now my math problem is set up. Notice that here's a fraction. This is not a fraction. I can treat this one like it is a fraction, though. I'll just put it over 1. And when we multiply fractions together, we multiply the numerators together. So 2 times 100 is 200. Meters times centimeters is going to be meters times centimeters. And on the bottom, I go 1 times 1, which is 1, and meters is the only unit there. Now, you'll notice I have meters on top of meters in this fraction. So those are going to cancel each other out, and what I'm left with is the unit I want and the number I want. So my final answer is 200 centimeters are in 2 meters. Let's do another example. Example number 2. How many seconds are in 35 minutes? All right, so let's follow that same process again. Unknown equal to known times our conversion factor. All right, well, the unknown value here is how many seconds. So again, I will represent that with an x and the unit, x seconds. The thing I know is 35 minutes, so 35 minutes. And now I need a conversion factor. So I could look this up, but I think most people know that 60 seconds equals 1 minute. So these are the values that are going to go in my conversion factor. Now again, the one I want, seconds, is what's going to go on the top. So that's going to be 60 seconds right here. And what I want to get rid of are minutes. They're going to go on the bottom. 1 minute right here. So I'm going to multiply these together. Let me get out my trusty calculator. And that's going to be 35 times 60. And I get 2100. So 2100 minutes times seconds, because those aren't numbers, they don't really multiply very well. 1 times 1 is 1, and then I have minutes on the bottom. And again, if I have something on top and something on the bottom, then I can get rid of both of those things, and what is left over is my final answer, 2100 seconds. Okay, let's do another example. How many milliliters are in 20 ounces of pop? So let's start out. Unknown equals known times conversion factor. So how many milliliters is my unknown? So that's going to be X milliliters. My known value is 20 ounces. The abbreviation is OZ. And now I need to multiply that times my conversion factor. Well, I don't know how many milliliters are in an ounce, so I need to find a conversion factor sheet that's going to tell me that. So milliliter or ounces are an English unit, milliliters are a metric unit. Here we go. 1 fluid ounce equals 29.57 milliliters. 1 ounce equals 29.57 milliliters. So those are the two, that's the pieces of the equality that go into the conversion factor. So the thing I want to keep is going to go on top. The thing I want to get rid of goes on the bottom. So 29.57 milliliters, 1 ounce on the bottom. So let's see what 20 times 29.57 is. And I get 591.4. Ounces cancel out ounces, and what I'm left with are milliliters, and that is my final answer, 591.4 milliliters in 20 ounces. Okay, one more example, and this time we're going to do a multi-step example. So, a certain science teacher, who will go unnamed, weighs 250 pounds. What is his mass in grams? Okay, so we start out, same process as usual. I take my unknown and I set that equal to my known value, and I multiply that by a conversion factor. So the unknown value is, what is his mass in grams? Mass in grams, so X grams. What we know is that he weighs 250 pounds. So that's going to be 250 pounds. And now I need a conversion factor, one that changes pounds into grams. Okay, so here is the deal. Changing pounds into grams may not exist on our chart. So here I have pounds, and if I look across, it's 0.454 kilograms. But it doesn't change anything into just plain grams. But if I look at this sheet, I can see that 1 kilogram is the same thing as 1,000 grams. So here's what I know. I know that 1 pound equals 0.454 kilograms. And I also know that 1 kilogram equals 1,000 grams. So this is what I know. I know pounds, and I want to get to grams. So what I need to do in this case is I need to set up two conversion factors. The first one is going to get rid of pounds and put it in terms of kilograms, and the next one will get rid of kilograms and put that in terms of grams. So the first conversion factor here, we want to get rid of pounds, so I go 1 pound on the bottom, and I put 0.454 kilograms on top. The pounds will cancel out the pounds. And I'm sorry, I used the abbreviation for pounds, LBS. Here I wrote out pound, but they're the same. Now, I have kilograms, but ultimately I want to get to grams. So now I have to change kilograms, 1 kilogram, into 1,000 grams. Kilograms cancel out kilograms, and now I've got 3 numbers across the top that I can multiply. So let's get out the calculator here. 250 times 0.454 times 1,000 equals 113,500 grams. Now that's a really big number. We wouldn't want to use grams to measure the mass of a human being because we'd have to talk in big numbers. We'd probably use kilograms rather than grams. But anyway, that is how you do a multi-step problem using, in this case, 2 conversion factors, but as you move on in science, you may use 3, 4, even 5 conversion factors sometimes. So that's all I've got, and good luck with your dimensional analysis.